Hello, everyone. Thank you for joining. I'm Jamal Arif, and I'm part of the Oracle Cloud Infrastructure team. Today, we are going to talk about Container Engine for Kubernetes. So, just to do a quick safe harbor statement, I'll just give you a minute to just read through the statement itself. So, the objectives of this course is to go over our Container Engine for Kubernetes. We'll talk about how you can launch a Kubernetes cluster on OCI, and also what are the prerequisites of launching a cluster. When you launch the cluster, how you can access that cluster using kubectl, and also the Kubernetes dashboard. Some of like for a prerequisites perspective, you just need to have a basic understanding of the Docker and the Docker container runtime and Kubernetes. So as we go into details on Kubernetes components, you just need to have a basic understanding of those components. All right, so moving forward, what are some of the ways that you can launch Kubernetes cluster on OCI? So the first step is that it's kind of a DIY model where just like any other cloud provider, from an core IaaS perspective, you have the core components of the infrastructure components of Oracle Cloud Infrastructure, and you can utilize those infrastructure components to set up your own Kubernetes cluster. Basically, just using the compute, the networking, and the storage services from OCI, and then installing your own container runtime, which can be Docker, which can be any other container runtime, or and then on top of it, installing your own orchestration system as well. So it can be again Docker's Swarm, or it can be Kubernetes, it can be Mesos. A bunch of different options are available, and all of them are kind of open sourced options that are available to you. But we call this method as a DIY method because it's you are just we are just providing you the core infrastructure components from Oracle's OCI perspective, but from like running all the container management on top of it is all customer based, so it's all on your end. That's why it's called a DIY model. The second kind of approach can be where instead of creating or installing all of the components yourself, there is a quick start available on Terraform with Terraform. It's currently available on GitHub. It's managed by the Oracle team, and they regularly manage it when newer versions are there as well. But it's a quick start experience. What it does is that it gives you quickly and like it quickly creates a Kubernetes cluster on top of OCI. In the next slide, I'll just talk about that what it actually creates as well. But there is a quick start experience that is available as well. From a managed service perspective, this is also partly DIY, do it yourself, because we give you a Terraform to set up the Kubernetes cluster, but at the end, you are still managing the cluster yourself. The last is what we can call as a container as a service. So this is where our managed Kubernetes service comes into play. We call it OCI Container Engine for Kubernetes. It's a managed service which allows you to create a Kubernetes cluster within a few minutes. And from there onwards, the master components are managed by the service itself, and you are only responsible for your own worker or compute nodes, basically your data plane. And this session primarily, and this course primarily, we'll target the last part, which is our managed service, which is the container engine for Kubernetes. So we briefly touched upon the do-it-yourself method. So the Terraform Kubernetes installer for OCI. So in the Kubernetes installer, it's based on Terraform, and it is developed by the OCI team, and it's available on GitHub. The link is available as well. What it does is that it creates a highly available Kubernetes cluster. So what that means is that, as you can see in the figure, it creates multiple master nodes. in different availability domains. So you can choose how many master nodes that you want to configure and also in which availability domains using the Terraform script that it is provided. It also lets you create worker nodes across different availability domains as well. Those worker nodes are again can be managed in a way that you can choose what kind of worker node shape that you want, a compute node shape that you want from the available compute shapes on OCI. You can also launch any bare metal node using that using this Terraform script as well, because all you need to do is that you just need to provide the shape in the Terraform variable file, the TF variable file, and from there onwards it actually creates that cluster for you. It also creates all the prerequisites or the infrastructure components. So it creates a virtual cloud network, the subnets, the load balancers, everything is also created with it. And just like we talked earlier, you can specify the number and the shapes of your cluster. It also lets you scale your cluster. So since it's based on Terraform, within the Terraform TF variable file, if you want to scale up the cluster, you can define the total number of the nodes, and it would help you scale the cluster as you need. However, in the previous section where we discussed the DIY model, there are a number of different challenges associated while you are managing the Kubernetes cluster yourself. And we have talked to a number of different customers, and some of the challenges that I've enlisted over here are some of common challenges that the customers face when you are managing the Kubernetes cluster yourself. Things like how do you find a path where you can upgrade your Kubernetes cluster to the latest CNCF version of Kubernetes. So every now and then the community comes out with newer edition of Kubernetes, and upgrading to the latest edition for a number of newer features is something very a common issue. How do you integrate with the number of different CI/CD options available and open source options available? What do you do about container networking and storage? How do you build out that overlay network for Kubernetes to run? How do you make sure that there is persistent storage available for your Kubernetes workloads? So a number of these things are there, and a number of challenges are there when you are trying to manage your Kubernetes cluster yourself. So that's where a managed Kubernetes service comes in. So what is the container engine for Kubernetes? Well, it's a managed Kubernetes container service to deploy and run your own container-based applications. It provides you to a tooling to create a standard Kubernetes cluster, scale it, manage it, and control your access to the Kubernetes cluster as well. What are the problems that it's solving? Well, as we were talking on the last slide, maintaining a Kubernetes environment is really complex. It's costly, it's time consuming, there's a lot of complexity associated with a number of different components on the Kubernetes master nodes or worker nodes, bunch of stuff. It's also hard to integrate Kubernetes with additional lifecycle, the container lifecycle management products. So you can say registry being one. What about the CI/CD frameworks? What about networking? What about security, storage? And in addition to this, how do you manage and control the access to your cluster? How do you figure out which team? How do you figure out that granular access control to your Kubernetes cluster? Well, Kubernetes Container Engine for Kubernetes is basically solving all those problems for you. It's built on the OCI underlying infrastructure, so it provides you to quickly spin up a cluster and also allows you to utilize the high predictable performance and the features like security, IAM, and control of the Oracle Cloud infrastructure. So if you look at the Kubernetes engine on OCI, uh, what is maintained by the customer and what is maintained by Oracle? On the left-hand side, you see the OCI registry service, which is tightly integrated with the Kubernetes engine itself, and the master components of container engine. So you have the cluster management of your overall masters nodes. You have multiple etcd nodes which are living across availability domains or fault domains, and you have the container engine dashboard, all are maintained by Oracle itself, by the service itself. What a customer is doing is only managing the worker nodes or the data plane or the compute cluster that they are creating, which can be virtual machine based or a bare metal based. Similarly, from a pricing structure, all the services that Oracle is providing are free from a managed service perspective, and customer is only paying for the resources they are using. So any of the virtual machines or bare metal compute nodes that they're running as their worker nodes, they'll be paying for those. And any of the storage they are using for persistence or any additional services like load balancer, they will be only paying for underlying infrastructure resources in that case. So just to summarize, what are some of the key features of our container engine? So number one, it's container native. So you get the standard Docker and the Docker runtime and the standard vanilla Kubernetes. The registry is completely integrated and it is fully Docker V2 compliant. You also have full integration to cloud networking and storage. So for instance, you can use load balancer for your services. You can also use the block volume service and the FSS for persistent storage. In addition, it is developer friendly, so you get complete full REST API, which basically allows you to automate the workflow of creating a cluster, scaling the clusters. You have built-in add-ons like dashboard, DNS, and Helm, and it's also based on open standards. So it's a standard Docker container runtime. It's a standard Kubernetes, and you can get direct SSH access to your worker nodes as well. And from an enterprise perspective, it's like you can run your worker nodes as bare metal nodes as well, and you can run them across different fault domains or availability domains, so giving you a high available application architecture. And everything is integrated with the identity and access management system. So you can really go granular on the IAM controls and policies, and allow only teams which have the access, which require the access, and the kind of and the scope of access that they require, so that you get that security structure set up for your Kubernetes cluster. In the next video, we'll talk more on how do you create a Kubernetes cluster on OCI. Thank you for joining.